So we're going to look at multiplying binomials. I'm going to show you two methods that you can do, and I'd recommend going through and solving. So this is where we have a binomial times a binomial. Both of these cases, they're going to get us a result, a polynomial result going through. So 2x plus 1 and x plus 2, I'm going to first use what I call the box method. And this is where we write one term on the top of the box and the other term on the side of the box, where each term gets its own row. So now when I go through and multiply, it's going to be x times 2x, which is 2x squared, x times 1, which is x, 2x times 2, which is 4x, and then 2 times 1, which is 2. Now, once I have all these terms, I can write them out, and I get 2x squared plus 4x plus x plus 2. And in doing so, I have these like terms here, so it's actually 2x squared plus 5x plus 2. Okay, let's go over and look at distributive property. Distributive property, in the past, when it was just a single term, so if it was something like this, you would have done 1 times x and 1 times 2. For this case, you can do it the same idea, but you're going to multiply each term in the first times each term in the second. So it's going to be 2x times x and 2x times 2. So 2x times x, 2x times 2. And then it's going to be 1 times x and 1 times 2. Okay, so in doing these, I now have 2x times x is 2x squared, 2x times 2 is 4x, 1x times x is x, and then 1 times 2 is 2, giving me common like terms here, which becomes 2x squared plus 5x plus 2. Both get to the same end result. Both kind of use the same parts, but I would recommend using the box method going through. It's going to keep you more organized. So just want to see that you do have that option, distributive property, if you just don't want to listen to me. All right, so let's go here. We got 2x plus 4 and 3x minus 7. 2x times 3x is 6x squared. 3x times 4 is 12x. 2x times negative 7 is a negative 14x. Can't forget the negative. And negative 7 times 4 is negative 28. So then I get 6x squared plus 12x minus 14x minus 28. But wait, again, I have these like terms here that I could combine, which are going to give me, it looks like, a negative 2x. But I had these like terms here as well, and these actually came from this diagonal, and these came from that same diagonal. And that's something that's going to occur. These like terms will show up on the diagonals. Not every time, but in this case, we can use those to help us out as well. So let's go to our next one. It's now m plus 6 and m minus 7. So m times m is m squared. I get a 6m, a negative 7m, and this will be negative 42. So then I have these like terms, so it's going to be m squared. Negative 7 and 6 is negative 1m, and negative 42. So we get m squared minus m minus 42. Our next one, 2x plus 7, 3x minus 4. We get 6x squared, 21x, negative 8x, and negative 28. This is 6x squared. I have a 21x and a negative 8x, which is going to be a 13x positive, and then negative 28. So 2x plus 7 times 3x minus 4 gives us this result. Now, if you're starting to see the pattern, maybe pause it, try the next few problems, and then you can go back and check to see if we're getting the same answers. For our next one, I have 4x minus 5 and x minus 3. I get 4x squared minus 5x minus 12x plus 15. This becomes a 4x squared. Negative 5 and negative 12 is negative 17x. And then plus 15. We're now looking at a minus 1 times a minus 11. We get a squared minus a minus 11a, and then a negative 11 times negative 1 is positive 11. So we're going to have a squared This together is negative 1 and negative 11 is negative 12a plus 11. Last one on this page for me at least, it's going to be 3x plus 1 and x plus 4. We get 3x squared, x and 1 is x, 3x and 4 is 12x, 4 and 1 is 4. So that's going to be 3x squared plus 13x from 1 and 12 plus 4. Work through a few more. Again, you could pause, work through to the word problem, see if you're getting the same answers. So we're going to go 3p times 2p is 6p squared. 2p times 4 is 8p. 5 times 3 is 15p. And 5 times 4 is 20. So this gives us a result of 6p squared. 15 and 8 give us 23p plus 20. Now we have 5x minus 3 and 2x plus 1. That's 10x squared minus 6x, because that is 2x and a negative 3. 5x and 1 gives us 5x, and then 1 and negative 3 is negative 3. So all of our terms, again, give us this. We still have like terms, so it's 10x squared minus x minus 3. So what if we then had something like 2p to the third plus 3 and 2p minus 5? Our first term is 2p times p to the third is going to be 4p to the fourth. Pay attention to your exponents. 2p and 3 is 6p. 2p cubed and negative 5 is negative 10p to the third, and then negative 15. Now why this problem is important is these two are not the same anymore. They're not like terms, so I'm just going to write them all out in descending order. I have 4p to the fourth, then negative 10p to the third, then the next one is plus 6p, and then minus 15. Now what if we have n minus 6 and n plus 6? So very close to each other, one's just opposite signs. I get n squared minus 6n, positive 6n, and negative 36. What happens on the like terms here is 6n and negative 6n actually become 0. So it's going to be n squared minus 36. Well, what if we had something where they're both the same sign, x plus 4 and x plus 4? We have an x squared, 4x, a 4x, and a 16. So this becomes x squared plus 4x and 4x is 8x, and then plus 16. Last one we'll do here, 4w plus 13 and x plus 2. Let's make them both. They're both different variables. All right, let's leave them separate. So I get 4xw, 13x, 8w, and 26. So in writing these out, these give us a variety of variables, but it also shows us we still have to be careful with like terms. These are not going to combine. We'd write it as 4xw plus 13x plus 8w plus 26. Not a typical result we get, but is the answer nonetheless.